Now we can do a question that only 32% of the people got right when they took it on an official GRE test. We're given a simple line of W, X, Y, and Z, and we're told on segment WZ above, if WY equals 21 and XZ equals 26, and YZ is twice WX, what is the value of XY? As we start to break down the problem, we're told that WY equals 21 and XZ equals 26. But as soon as we see 26 and 21 and we see answer 5, we get really suspicious about that answer because we aren't even finished reading the problem. We shouldn't be able to get the question and the answer this quickly. We're also told that YZ is twice WX, and then we're being asked what is the value of XY, which is the little segment in between the two other segments. That's the part that 21 and 26 are overlapping. We realize that we've got lots of information, maybe too much information, but a lot of people think they can't figure it out, and so they want to pick answer E. We should be really suspicious about that because the quantitative comparison questions are always looking for answers that say it cannot be determined from the information given. Why would they make that the answer to a multiple choice question? Don't pick it just because it looks too intimidating. We should be able to solve this problem since we're given 3 line segments and we have 3 facts. We know that WY equals 21, XZ equals 26, and YZ is twice WX. But we can take advantage of the fact that the nerds are going to put the predictable mistakes in the answer grid so that all of your friends could find those predictable mistakes. Since we know that YZ is twice WX, we can look at our answers and we can realize that 10 is twice 5. So let's say that 10 was our YZ and 5 was our WX. Since WX is part of our WY that equals 21, we realize that 5 plus 16 equals 21. And since YZ is part of XZ, which is equal to 26, we realize that 10 plus 16 equals 26. And since we're looking for the thing that showed up in both of those connections, we find that 16 is what XY is, and D is our answer. Of course, most people used algebra to solve this problem, so we can make up 2 equations. We know that WY equals 21 and XZ equals 26, but those lines are actually broken up into line segments, so that we know that WY equals WX plus XY, and that equals 21, and XZ actually equals XY plus YZ, and that equals 26. Now we see we have all 3 line segments in the 2 equations. XY is in both equations, and WX is part of our WY equation, and YZ is part of our XZ equation. And then we can substitute. Since we know that YZ is twice WX, XZ equation on the right actually turns into XY plus WX, and that equals 26. Now we see we have common elements in both equations. XY is in both equations, and we have 1 WX in both equations, so we can cross those out, and we can cross out 21 from both sides, and then we're left with WX equals 5. Boy, doesn't that answer A, 5, look really inviting? Do you want to pick it? But we've only found Wx, and Wx is part of Wy, which is equal to 21, so that would mean that xy would have to equal 16. Then we remember that yz is twice Wx, so that if Wx equals 5, then yz equals 2 times 5, and yz equals 10. Doesn't answer B, 10, look really inviting? Do you want to pick it? But yz is only part of xz, which is equal to 26, so if yz equals 10, then xy equals 16. So either equation gives us xy equals 16, and that means our answer is D, 16. Testing for the public. Nonprofit since 1985. No one makes things easier.